Hi there, and welcome to the latest in our webinar series on Oracle database upgrades and migrations. You'll see that the title of this webinar is AutoUpgrade 2.0, and that doesn't mean that we've got some huge new release of AutoUpgrade, because that tool has been incrementally improved in the more than 3 years since it's been released. What we're talking about here is going a level deeper with AutoUpgrade to talk about those real-world use cases that can so often complicate your use of Oracle database. I'm talking about things like encryption and rack and multi-tenant and data guard, or maybe combining any or all of those in your environment. How do you use AutoUpgrade there to make your upgrades and migrations as productive and efficient as possible? So that's what we're going to talk about today. And let me introduce the team that you're going to hear from. My name is Roy Swanger. I'm Vice President for Database Upgrades and Migrations here at Oracle, which means I'm responsible for things like the database upgrade and AutoUpgrade and DBUA, but also data pump, SQL loader, transportable table spaces. Basically, if you're upgrading or migrating to a new environment, you're using the stuff that's developed by my team. Now, for product management, you're going to be thinking about Mike Dietrich, our world-renowned expert in Oracle database upgrades and migrations. He's the Senior Director for Product Management for Oracle database upgrades and migrations. He's based out of Germany, and I'm sure you've been to his blog or seen our previous webinars or are a subscriber to his Twitter feed. Based out of Denmark is Daniel Overby Hansen, a senior principal product manager who focuses on cloud migrations. And also on the side, Daniel really is a driving force for our YouTube channel. He takes a lot of the content that we produce from these webinars and other sources and produces bite-sized videos on very specific topics that you can get from that YouTube channel. So if you're getting those videos, you're seeing Daniel's good work. And also joining us today is Senior Principal Product Manager Rodrigo Jorge out of Brazil. Rodrigo is an expert in all of the MAA techniques such as rack and data guard, and also very deeply involved in database security and patching. So you'll hear some really good wisdom and really good technical details from Rodrigo as well. Now, before we get into the content, let me answer the very first question that comes to mind every time you watch one of these webinars, and that is, where do I get the slides? Go to Mike Dietrich's blog. You see the URL on your screen there under the slides category, and the slides for this webinar will be available as soon as you are seeing this webinar live broadcast. Of course, we have our series of webinars that you might want to take advantage of. If you've missed any of them, they're available for free on demand. You see the link here. And these can be very specific topics like how to use the cloud for performance testing of a migration, or very general topics like performance testing in general or best practice for upgrade. The library is still there, still accessible. It's been viewed by thousands of people around the world, so we hope you find it useful as well. And let me close this introductory session with the one key bit of advice that we will always tell you about using AutoUpgrade, and that is to get the most recent version of AutoUpgrade anytime you're going to use it. Even though AutoUpgrade is included in your release updates, so you'll get a fairly recent version in the latest RU, the development team is very productive and very agile, and you'll find in many cases that even if you have the latest RU, there might be a new version of AutoUpgrade with bug fixes, with enhancements, new features available in the My Oracle support note. So click on the link and download it from there. With the introduction out of the way, now I'd like to hand you off to Rodrigo, who's going to start talking about using multi-tenant with one of those really neat features of refreshable PDB clones.
Thank you, Roy. So the first feature for today's webinar is cloning a non-CDB or PDB using the refreshable clone strategy. So let's see this strategy in action on the next slides. So first, let me explain the concept of refreshable clone. With refreshable clone, we create a DB link from the target environment pointing to the source environment. And when we create a pluggable database using this DB link, we tell to the command how often we want to keep refreshing this PDB. So for example, you can keep refreshing it every 30 minutes. So in every 30 minutes, it's gonna only take the delta since the last refresh. This can significantly reduce your downtime because you don't need to move your full PDB from one environment to the other. You can just keep refreshing it and keep your environment online while you are doing this operation. Finally, when the upgrade times comes, you do a final refresh, which will only take the final delta. It will upgrade your PDB and open it. This is a great strategy, especially if you're not just upgrading using AutoUpgrade, but also migrating to a new server. You can also use this not only for PDBs, but also for non-CDB to PDB. So don't forget that you can create a refreshable clone using a non-CDB as a source environment. The only thing is that after the upgrade, AutoUpgrade will perform for you a conversion step, which will convert this non-CDB to a PDB. You can also determine the point of synchronization, meaning you can specify in seconds for the refreshable clone how often it's going to refresh your PDBs. Also, it's important to keep in mind that all the constraints that we have when we unplug and plug a PDB in another CDB also applies for this. And one of them is the components. Don't forget that your CDB must be a superset of all the components you have in all the PDBs. Meaning, if you are moving a PDB from the source environment to a new target environment, you need to have in your CDB all the components that you have in that new PDB that you are just plugging in. Now let's see the PDB upgrade concept working with AutoUpgrade. So the PDB upgrade concept in AutoUpgrade is that we simply unplug, plug, and upgrade. And this already works with database links. First, we need to prepare our environment here. And in the source CDB, you need to create a user on the container database and grant some sys privilege to it. Don't forget to also grant read on the sys $enc table, because this is a requirement, especially when you have encryption enabled in your source environment. Now on the target CDB, we need to create a database link using that user that we create on the source CDB. Another thing you cannot forget is that you may run the fixups before you start your clone operation. So your PDB will be already prepared and with all the fixups applied that's needed to perform this refreshable clone operation. Let's see an example of a config file for this refreshable clone. First, just for a PDB upgrade without being a refreshable upgrade. So we have this source DB link parameter here pointing to the DB link that we created. Also the PDB name and the copy operation here, showing that we want to copy the database files. Now, if we want to use the refreshable clone, we also provide a second item here to this source DB link parameter. And this number here that we are specifying in this example is 60. It defines how often we want to refresh this PDB. So here we are refreshing the PDB every 60 seconds. And finally, the start time here is in 1 hour and 30 minutes, meaning we are refreshing the PDB with the deltas every 60 seconds. And finally, in 1 hour and 30 minutes, we will start the upgrade action. If we check the log file, we will see that every 60 seconds in the log file, we will have a refresh entry happening here. Finally, AutoUpgrade will always issue a final refresh before the upgrade starts. Now with Mike, that will show you a live demo of this feature in action.
So thank you, Rodrigo. This was excellent. Now you have seen the details about how AutoUpgrade can ease creating refreshable clones. And you've seen what's happening in the background and everything you need to know. But let's have a look into a demo and see how the feature really works. We will start in a demo with the preparation steps. We need a clone user with some privileges. We need a database link going from the target CDB into the source CDB, and then we will run AutoUpgrade. So let me start here with the source CDB. So we have the clone user here, C##org, and the clone user needs some privileges. In addition, I do a listener setup correctly here. If your listener is set up correctly, you don't need that. So this is in a script I called setup.sql. I execute it. Now the things are created in my CDB $root in the source, and in the target CDB, I create now the database link, going back, utilizing that user. So start link will create a database link. Then I have a config file. So my source is 12.1, my target is 19C. My source CDB is a 12.1 CDB1 with 1 PDB. And I'm going to my target CDB. This is CDB2 in my 19 environment. Very important, this database link is key. And you see the 60. That means every 60 seconds do a refresh for 10 minutes before you start the upgrade. The PDB keeps its name. It's still called PDB3. And I would like to have the files moved to have a seamless rollback in case of a failure. Now I start AutoUpgrade. And the first step is that we do an analyze. So let us do an analyze here. And the analyze completes very, very fast. Here is the result of the analyze, all good. And so I can run the fixups. This is important here because as part of the refreshable clone, AutoUpgrade does not run the fixups automatically. So I need to run it. Let me check here the job 101, and we run the free fixups in the source PDB3 here. And quickly after the fixups finish as well. And now it's time to start the deploy. And this will now create a copy, a refreshable clone, and roll forward, a refresh forward for 10 minutes, because that's what I defined in my start time here. The remote is there. We can have a look at the logs, because I don't want to type LSJ all the time. So I quickly climb down into the depth of AutoUpgrade logs. There's this state HTML, and I will pass this onto my browser, and it auto refreshes itself. So I don't have to do anything. I can just sit there and watch it from now on. While AutoUpgrade is doing something, I hit return and do a quick check with LSJ again. And it says, yeah, it starts in 8 minutes because I defined start time plus 10 minutes. So the idea is every 60 seconds, it does now a refresh. Let us monitor this in the alert log. That is the safest place. And you see at 21:39, there's a refresh triggered, and this completed just a second later. And while we watch that with a tail -F, we'll see a minute later, there's a refresh happening again, and it's completed again. And we can watch this now for a while and see how it refreshes forward. But meanwhile, I would like to create something in my source PDB. So I connect to my PDB3 on the source, create Scott. Scott was missing here, give Scott some useful privileges, create a table, and insert a row into this table owned by Scott. Back to the alert log, and here we see a minute later, 21:41, 42, and so forth. So I scroll here a little bit forward, and we'll see every minute this refresh is now happening because I define it that way. Now 46 here, 47, and at some point the upgrade will start. And here it is. Now you see there's a change, there's no refresh. AutoUpgrade has done the final refresh and then started the upgrade. Let us check here, status -job 102, and it's in upgrade mode. And now I go back to my browser page because this is why I opened it. So we will now safely lean back and relax. And of course, I do a little bit of fast forwarding here because nobody wants to watch for 13 minutes. We see 23%, 37, 39, 91. And then the upgrade is done. So unplug work, post checks if needed, and finally completed. That's it. You don't trust me? Let's have a look and connect to my 19C PDB now. Alter session set container PDB3. Select star from Scott tab 1. Here it is. So you see, this is really no rocket science. And it's so smooth. It's really cool. and you avoid all the copy time. Just think your source PDB is 6 terabytes, and you would need to copy it over until you can start the upgrade. So you determine the synchronization point. That's really, really good. And the best thing is, the source PDB stays intact all the time, so you can safely roll back to the source. And of course, you want to test this several times. So for testing, this is an ideal situation here. Really, really helpful. And believe it or not, you can do the same thing with non-CDBs. Yes, that's possible. Even though the source is not a PDB, we can do the same technique or use the same technique to migrate a non-CDB now into a PDB. So includes pre-upgrade, cloning, upgrade, and also the conversion of non-CDB to PDB. So it will be moved over and then plugged in, upgraded, converted. All that happens and can be done also with a non-CDB as source with an AutoUpgrade. So this can really, really ease your future migrations into multi-tenant environments a lot. So what do we have to do? Again, we start with a few preparation steps. Now we don't create a C## user because there's no common users in non-CDBs. We create a regular clone user here, and a clone user gets some privileges, the same privileges as before. In addition, the target CDB needs a database link pointing to the source, utilizing that clone user. Same thing as before, no difference. Then in my AutoUpgrade config file, you see the SID of the source. Here I named it non-CDB. Then source DB link dot non-CDB. This is the database link I created on the slide before. In this case, I would like to have a new name because I want my PDBs have all a remarkable sign that it is a PDB now. And for the copy option, I think this is really essential and extremely helpful because again, I want my source stay intact. In case something goes wrong, I easily can go backwards. And remember from our previous seminars, this is a migration. So fallback is not trivial, a rollback is not trivial. And in this case, we have the source still stay intact, even though it takes more time to copy it over. But here we have a relief because we can use the refresh option here as well. And this makes it extremely attractive now. We can clone the non-CDB, make it a PDB, but we can refresh also with the redo. So if your source is now 10 terabytes, we refresh forward, no problem. Here, I would like to refresh. You see the last line, start time 45 minutes. After the cloning operation has been completed, for 45 minutes, I would like to have a refresh every 300 seconds. So every 5 minutes, and then the actual upgrade and migrations start. At this point, then I, of course, need to stop my source application if this is my live move. But I don't have to wait for my 10 terabyte database to be copied over. That's really a key technique here. And again, the source non-CDB stays intact. It allows you a seamless rollback, which we think is really key, especially in such cases. And certainly you would like to test this several times. So once the clone operation is completed, you can remove the clone user. So a little bit of cleanup is quite good, and also the database link, because we don't need that user for any other purpose than for the cloning. So just keep that an eye on here. And one thing we would like to point out, be very cautious when you have to when you have standbys somewhere. And Daniel will explain later on in more detail why standbys can here be really a tricky thing.
Thanks, Mike. And now to something completely different: transparent data encryption. With the increased adoption of cloud technologies and the focus on security, more and more of you are using encrypted databases. This also means that AutoUpgrade must be much better at working on encrypted databases. Previously, we had a limitation when it came to encrypted databases. only certain operations were allowed, but we had a little feature gap. And the reason for that was that AutoUpgrade didn't have any functionality for storing sensitive information, like for instance, the database keystore password. But we've changed that. Now, AutoUpgrade has its own private keystore that it can use to store sensitive information, like for instance, the database keystore passwords. What better way of showing you this new functionality than a demo? So let's just jump right into it, and I can show you the new cool functionality. I'll show you how to do an unplug-plug upgrade of a PDB from one CDB to the other. In my source container database, you can see in my PDB that I have an encrypted tablespace. This is my AutoUpgrade config file. I'm unplugging from CDB1 and plugging PDB1 into CDB2 where it will be upgraded. And because it has encrypted tablespaces, I'm specifying this new global.keystore parameter. Now let's try to do a pre-upgrade analysis to see if I'm ready to start the upgrade. After a while, the analysis completes and I can check the summary report. Oops, there is a problem. There is an error in the check TDE passwords required. Okay, makes sense. I have encrypted tablespaces. So let's dig into the pre-upgrade log for some more details. I scroll down a little and I find the before upgrade required actions. I must add the database keystore passwords for the source and target container database. So let's go ahead and do that. I'll start AutoUpgrade using the load password command line option. This is the first time I do that. So in order to generate an AutoUpgrade keystore, I need to specify a passphrase or password that protects the AutoUpgrade keystore. Once I've done that, I can start to load in the database keystore passwords into the AutoUpgrade keystore. Then later on, when needed, AutoUpgrade can fetch the database keystores from the AutoUpgrade keystore. I've input my two passwords, so now I save them into the AutoUpgrade keystore. Now let's try to redo the analysis. AutoUpgrade detects that there now is a keystore and it prompts for the password to open the AutoUpgrade keystore in order to read the database keystore passwords. Now the analysis has completed again, so let's check the summary report. And this time all is good because I've input the database keystores. There is nothing preventing me now from starting the upgrade. So let's do that. Restart AutoUpgrade in deploy mode. Again, AutoUpgrade wants to read from the AutoUpgrade keystore and it prompts for the password that protects it. Once I've input that, everything should start. Quick LSJ. Looks fine. So let's just skip ahead in time. And now the PDB has been upgraded. Yeah, but let's just verify that. I reset the environment to the target container database and connect to the database. In my PDB, I'll just try to create a new encrypted tablespace just to ensure that everything works as it should. And as you can see now, I have users tablespace from before and the new users 2 tablespace that I just created. With what we just saw in the demo, I can say that AutoUpgrade now fully supports transparent data encryption. There is a small niche area when it comes to transparent data encryption in container databases. It's called isolated keystores. It was recently backported to 19C and we haven't yet implemented full support for that feature. But it is a niche functionality and I expect that most of you are using the unified keystore mode, which is fully supported in AutoUpgrade. But if you are looking at using isolated keystore mode, you should watch out for one of the coming versions of AutoUpgrade, where we will implement that as well. Now over to Roy for some more details about the AutoUpgrade keystore.
Thanks, Daniel. Now that you know the general capabilities that we've implemented in AutoUpgrade regarding TDE, let's talk about how to get set up to use them. The first thing you need to know is about the new config file parameter, global.keystore. So this is a global parameter for AutoUpgrade. And in your config file, this will tell us where to look to find your TDE keystore or wallet. Initially, it's going to be a password protected keystore, but you can configure it to be auto login if you want. So that parameter I mentioned, global.keystore, it's simply a location on disk where that file is located. Here you see an example of it being located in the operating system, and the permissions on that file are pretty restrictive. It's a 600 protection mask, so only system gets access to it, not group, not owner. What goes into that keystore? Well, you've got two things. You've got your set of passwords that you provide for access to your TDE encrypted databases, but then there might be Oracle managed and Oracle created passphrases or secrets that are used for things like external clients, like say Golden Gate, that needs to connect to a database to extract or apply changes to that database. Now you could have multiple sets of credentials in there. You could be upgrading multiple databases on the same system, all using the same keystore, for example. So how do you load the parameters or the password for one database? You use AutoUpgrade with the -load password parameter. That will get you into the TDE console or command line interface where you can add a TDE password for a particular database. Beyond that, you can manage your entries in this wallet because, as I mentioned, you might have multiple databases being upgraded on the same system. So you could add more passwords. You could delete passwords when you're done upgrading that database if you want. You can list the passwords that are available and so on. And of course, there's built-in command line help. So there are two layers of passwords here, and this is where often using encryption can get a little confusing. So we have a password for the keystore, which itself has passwords stored within it. So if you have a password protected keystore, then you have one password that protects the keystore itself, and then you have loaded database passwords into the keystore. You can get rid of the need for that first password by configuring as an auto login keystore so that you don't need a password to open the wallet itself. In order to do that, you again use AutoUpgrade with the load password parameter. And then all you do with the TDE console is you type save, and you'll get the option to convert that wallet into an auto login wallet or auto login keystore. That will be that cwallet.sso file. So the password protected one was the e-wallet.p12 and the auto login is cwallet.sso. And from that point on, the wallet will just open when needed. So the last bit of advice I'll give you on the setup phase is to protect that auto login keystore. After all, this is the keys to your kingdom. Your TDE password is in there. And what's the point of having an encrypted database if you don't protect the encryption keys themselves? You need to protect them against both malicious and accidental loss or misuse. So the malicious part, you want to have appropriate protections on the files. You want to make sure that you're auditing access to those files so that if someone unexpectedly accesses the key store, you know who it is and when and why, for example. And in terms of accidental damage, well, of course, you want to make sure they're backed up and protected just like you would any database file. So now we've got you set up with your key store for AutoUpgrade. I'll turn you over for Mike to talk about some of the use cases.
Thank you, Roy. Let me go now a bit more into details. To upgrade an encrypted non-CDB or a CDB, the key store must be set to auto login. This is a requirement for AutoUpgrade. If your key store is normally not on auto login, you change this for the duration of the upgrade and then you change it back. One message we would like to really make clear here is that the new AutoUpgrade key store is not a requirement for upgrading an encrypted database. It just allows you, or allows AutoUpgrade, to go end to end, especially for the plugin. Whereas in previous incarnations of AutoUpgrade, we had to halt and wait until you pass on your password. Now you can give it up front to AutoUpgrade, and AutoUpgrade safely stores it encrypted in our own key store. And this then allows AutoUpgrade to progress it from end to end for you. But before we go forward here is just a workaround. In some scenarios, we have seen problems in finding the key store with AutoUpgrade. And if you have such issues, please remember these two variables in the AutoUpgrade config file: source tnsadmin.dir and target tnsadmin.dir. Almost all situations where AutoUpgrade has a problem finding the right key stores, these parameters help to direct it to the correct key store for the database, not for its own. And in releases before 19c, the default was that you defined the location where your key store is located in SQLnet.aura. But this is not very flexible, and it's not bound directly to the database. And it's actually very error prone. So with 19c, there's a new default. It's called wallet_root, and this is not on SQLnet.aura, but an SP file parameter. And you can really tie it to the database. The SQLnet.aura behavior is deprecated, which means you still can use it. It's not deported or not taken away, but we would highly recommend that you move to the wallet_root. For instance, if you use AutoUpgrade on an Exadata system, then it will do the migration to wallet_root for you. And I will show you how that works. And of course, also, you don't have to be on an Exadata for that. It works everywhere. But this is the default when you upgrade on an Exadata with AutoUpgrade. So you use AutoUpgrade to migrate to the new wallet_root. And in order to do that, you first need a small text file. And in this text file, you define two parameters for your SP file: wallet_root, the new one, and TDE configuration. And then you pass on this text file with the two parameters to AutoUpgrade. And you do this via add during upgrade p file and add after upgrade p file. So during the upgrade and after upgrade, AutoUpgrade has now the correct parameters, and even more sophisticated, AutoUpgrade will migrate your files, will copy it over to the new location. So AutoUpgrade does the migration for the wallet root topic. It just simply end-to-end does it for you as part of your upgrade to 19c. So to upgrade an encrypted non-CDB and afterwards convert it into a PDB, before AutoUpgrade had to halt and wait because we needed your key store password for the CDB. And you couldn't write it anywhere, and AutoUpgrade can't, like on the command line or whatever, that's not possible. So this is where AutoUpgrade has now its own key store for. So what you do in your AutoUpgrade config file, you define the location where the AutoUpgrade key store should be located. So like I do here, key store, and then you see in the AutoUpgrade directory key store. This is where AutoUpgrade has its own key store then. And standard parameter, when I would like to plug in now my DB12 non-CDB database, and it should become a PDB part of CDB2, the container database, I use the target CDB parameter. That's not news. Now, one additional step is required. You first run the analyze with AutoUpgrade, as you did before and as you usually do based on best practices. And this analyze will tell you which passwords AutoUpgrade will now require in its own key store to process your upgrade and migration end to end. So in my case here, it will tell me, hey, I need the DB12 key store password, the TDE password, and I need a CDB2. So what do? You go now in AutoUpgrade and you enter the TDE console of AutoUpgrade. This is brand new. So java -char AutoUpgrade char, your config file, and then -load_password. And this opens the TDE console. So instead of the usual UPG in AutoUpgrade console, you see now TDE. And there you say add DB12, add my password for DB12, and it will ask you for your password, and then add CDB2, and it will ask you for your CDB2 password. You store them. They are now in AutoUpgrade's own key store, protected and encrypted. And now, as always, you start just the upgrade in AutoUpgrade with -mode deploy. And this will now upgrade the DB12 database to 19C and then plug it in. Both are encrypted, everything handled by AutoUpgrade end to end. And when you would like to do this with Unplug-plug, so you have an encrypted PDB and you would like to unplug it from the same CDB here, CDB1, and plug it into CDB2, exactly the same thing. Again, you define in your AutoUpgrade config file the location of AutoUpgrade's key store. And in addition here, one parameter, because we don't want to upgrade the entire CDB1, we would like to plug in PDB1 into CDB2. So we have to specify it with PDBs. If you have more PDBs, you separate them by commas. Then again, you call AutoUpgrade with -mode analyze. It will tell you which encryption passwords it requires in the AutoUpgrade key store. In this case, we need a password for CDB1 and a password for CDB2. You define that as before with AutoUpgrade now -load password to enter the TDE console of AutoUpgrade. You add CDB1 and then you type the password, and then you add CDB2 and you type the password for CDB2, and then you run AutoUpgrade with -mode deploy, and that's it. And then it runs the entire thing end to end for encrypted databases. AutoUpgrade also supports converting an encrypted non-CDB, of course, into a PDB. And with that, I think Daniel has more to say and even more to show here. So over to you, Daniel.
Okay, that's great. Let me finish this chapter about encryption by talking about Secure External Password Store. Secure External Password Store is functionality that you can use together with encrypted databases to make operations easier. If you need to know more about Secure External Password Store, visit the slide deck. There's a hidden slide with some very useful links to the documentation and some really good blog posts. In this demo, I'll show you how you can upgrade a non-CDB database from 12.2 to 19C and convert it into a PDB. I'll also show you how the target container database is configured with a secure external password store, so I only need to load in the keystore password of the non-CDB database. Normally, you would need the keystore password both for the non-CDB and the container database. But since I'm using Secure External Password Store, I only need the keystore password of the non-CDB database. I could also configure Secure External Password Store both places, and then I wouldn't need to enter any keystore passwords at all. But for the sake of the demo, I'm going to do a combination and show you that AutoUpgrade can handle each scenario. So let's dive right into it. I'll set the environment to my non-CDB database and connect. You can see here that it has an encrypted tablespace called users. This is my AutoUpgrade configuration file. It's fairly simple. I'm upgrading DB12 and plugging it in to CDB2. And because there are encrypted tablespaces, I'm specifying the global.keystore parameter. Let's go ahead and analyze the database. It takes a little while before AutoUpgrade produces a summary report. Let's check it to see if there are anything we need to fix. As expected, there is a failure. We need TDE keystore passwords. Let's look at the details in the pre-upgrade log file. I'll find that there are some required before upgrade actions. I need to load in the keystore password for DB12, the non-CDB, and for CDB2, the target container database. Both passwords are needed for this operation. So let's start AutoUpgrade with the load password command line option. It's the first time I'm using the keystore, so AutoUpgrade will create a new one and prompt for a password to protect it. Then I can load in the database keystore password for my non-CDB. And then I choose to save that password into the AutoUpgrade keystore and convert it into an auto login keystore, so AutoUpgrade won't prompt me for the keystore password when it starts. Then I'll set the environment to my container database. I verify that the secure external password store has not been configured yet. The parameter is empty. So let's do an alter system and set the parameter. It points to a directory in the file system where the external store will be located. It's a static parameter, so we need to quickly bounce the database. And now I can load the database keystore password into the external store by using the administer key management command and adding a secret. For client TDE wallet means this is the database keystore password. So let's reanalyze the database again. We loaded in the password for the non-CDB, and the container database is now configured with secure external password store. AutoUpgrade doesn't prompt for the AutoUpgrade keystore because I created it as an auto login. The analysis completes, so now let's check the summary report. There are no problems because AutoUpgrade has access to the keystore password of the non-CDB, and the container database has secure external password store. So let's just go ahead and do the upgrade. Again, AutoUpgrade doesn't prompt for the keystore password. And now the operation starts. Let's just skip forward in time. After a while, the job completes. The database has been upgraded and converted to a PDB. So let's connect to the target container database. I can see that the PDB has been plugged in DB12. It is opened in read-write mode and unrestricted, so all looks good. Let's switch to the PDB. We can see that the encrypted tablespace is there, and the keystore looks fine as well. So that was it. You can upgrade and convert an encrypted database using a combination of the AutoUpgrade keystore and secure external password store. So I wish you good luck. Get started upgrading on all those encrypted databases.
Okay, I think that's everything you need to know about using TDE and AutoUpgrade together. Now let's make a complete shift in direction, and we're going to talk about one of our exciting new features of AutoUpgrade, the REST APIs. Now, the reason we created the REST API for AutoUpgrade is that one of the questions we often get asked by customers who are very happy with AutoUpgrade is, well, can I use this to upgrade a database on a remote system? And the answer is now, yes, you can. Using our REST APIs, you can be at a client or a web browser somewhere and upgrade a database on a remote system. And this has a lot of advantages because REST APIs give you stateless access to the AutoUpgrade functionality. And by that, I mean that you're not tied into making sure, for example, that your xterm with the AutoUpgrade command running over an SSH terminal connection actually stays up for the full duration of the upgrade. You can start an upgrade, you can come back and check on its progress later and not have to worry about having that stateful connection for the whole time. So this is a really nice capability, especially for those who want to develop their own automation and tooling. So how does it work? Well, there are a few moving parts here. First of all, of course, you've got to have AutoUpgrade on the database server where you want to perform the upgrades. You also will need Oracle REST Data Services, or ORDS. That is the Oracle REST API kind of subsystem that can be used to run any number of different APIs, whether it's AutoUpgrade, Data Pump, lots of other ways that you can access the database using ORDS. And then you have the remote user, which can be anywhere in your enterprise as long as they can connect to the server where you want to perform the upgrade. The requirement is that you have ORDS 22.1 or later installed in order to use the AutoUpgrade APIs. Once you have that, that user starts the connection, connects to ORDS on your database server. ORDS invokes AutoUpgrade to upgrade the database. In order to do this, there's just a few simple configuration steps that you need to put in place. One is to enable the specific API set that you want to use, in this case, AutoUpgrade. Then you have to tell us where to put the log files for the invocations of that AutoUpgrade API. You need to tell us where the AutoUpgrade jar exists on that system. It could be in your Oracle home, sure, but you could have a newer, more updated one in a central location. Maybe you want to use that same AutoUpgrade for multiple different Oracle homes, for example. And then finally, you have to tell us where ORDS should invoke Java from in order to invoke AutoUpgrade. Because remember, AutoUpgrade's jar file is run using Java, and you might even have different versions of Java on your system for different purposes. So that's all the config you need for AutoUpgrade. A couple of tips here. First is to use a separate instance of ORDS for the AutoUpgrade functionality. The reason for that is that performing an upgrade is not something you want just anybody to be able to do. So when you're accessing remotely via a REST API, you want to make sure that that instance is very focused in what it is being used for, because it's essentially doing sysdba work, upgrading a database. And you want to have that instance protected by a firewall so that only authorized users are able to upgrade your databases remotely. Let's walk through a demo of how this works, because I think that makes it a bit more clear of how to go about configuring REST API for AutoUpgrade. So the first thing we're going to need to do is have a location to put everything. And we have, in this case, a directory AU for AutoUpgrade REST. And in there, we have the AutoUpgrade jar file and the ORDS jar file. You can see that's still less than 100 megabytes total between the two of them. We'll unzip ORDS into a directory, and then now that we have an ORDS installation in place, we need to configure it. And that is going to mean invoking its configuration utility to provide information such as where is the config information going to go, what protocol is going to be used. For example, do you want to use HTTP or secure HTTP to access that? And then we'll talk about things like, well, do you want to use the self-signed certificate or provide your own? And pretty simple configuration at that point. Now, once we've done that, then we go through those AutoUpgrade config steps of enabling the API, specifying the log location, telling ORDS where the AutoUpgrade jar file is, and then telling it which Java to invoke when it wants to run AutoUpgrade. Pretty simple, just a handful of commands. You've got ORDS installed, you've got AutoUpgrade configured to be run with ORDS, and you're ready to upgrade your database. So once you have this configuration done, now we can get into how do you use the REST API, because your config file and your REST API invocation will be a little different. So I'm going to hand you off to Rodrigo to give you all those details.
Thank you, Roy. Now let's talk about the JSON file that we need to provide to the post method when we are submitting a new job. So if we were using AutoUpgrade, using the binaries, using the jar file, then we will provide a config file like this. Take this as an example. If you want to create a JSON file for the REST API, the structure is pretty the same. The only difference that instead of using the variable pair method, we use a JSON structure for it with the attributes and their values. So for example, for the global variables here, we have a global section in our JSON. And for a given global parameter, we have the attribute here inside the global section in the JSON file. Now, for the database local parameters, we also have a jobs structure in the JSON file where it's a vector. And for each entry of the vector, we specify the parameters for a given job. So if we had, let's say, in the config file, a UPG2 entry, then we would have another structure of this vector here. We would have a comma in the end, and then we would start another vector with the same entries. Now let's talk about the REST API methods and endpoints we have. So we have the test endpoint, which is the main one. This one is that we start with posting, meaning creating a new task. So the post method for the task endpoint is when we submit a new job for our AutoUpgrade task. The get for task means that we want to get the status of a job that's running in AutoUpgrade. The tests, the second endpoint we see here, tests, is the only one that we don't need to provide anything to it. When we run a get against this endpoint, we are going to get the list of all AutoUpgrade tests that we have in our system. The status, progress, console, and log, for those 4 endpoints here, we need to provide which test we want to get the status or which test we want to get the progress, the console output, or the log files. So for these 4 endpoints here, we need to provide the task ID, and the task ID is given to us when we post. So in the first method here, when we post a new job for our AutoUpgrade. So first, again, we use the task endpoint to create a new AutoUpgrade task. Then we get this task to use on the status, progress, console, or log endpoints. So for example, here, I'm running a post method, which is equal to running AutoUpgrade.jar minus config mode analyze. Here we see that in the endpoint, I'm putting mode equal to analyze. So let's understand all the entries we have here in this curl call. -K first is to ignore the verification of the certificate, because usually when we create a REST web service in our server, we use a self-signed certificate. So this -K is just not throw an error and ignore this certificate because it's a self-signed certificate. -data binary is the input JSON that we are providing to this post method. Here is what method we are using. For this, we are using the post one. And header, we are specifying that the input file we are providing, which is in binary, is actually a JSON file. And finally, the endpoint. Here, we are running against the task endpoint using the post method and also using the mode analyze, meaning we are creating a new job in the analyze mode. So the output is like this, and we can see that in this output, we have the task ID, and this is like a PK for this task, which we will use in all the other endpoints to get the status or to get the progress and also the log files of a given task. So we note down this number. And now let's say, for example, I want to get the list of all the tasks. So here I also have the task ID for all the tasks in this case, not only the one that I submitted. So now let's go on the test endpoint, but using not the post method. Here, I'm omitting the method. I don't have -X get, because when I don't specify anything, by default, it's the get method. So here I'm getting a specific test status. And here I get the result. And you see here status finished, meaning that my analyze mode is done. Also, I can get the console output for a given job. So again, I provide the task ID. I use the console endpoint. And this is the output I would have if I was running AutoUpgrade connecting our system using the Java call. So there in the console, I will see something like this. So this is simply the output of our AutoUpgrade job if you want to see it in text mode. And here we see that the job finished without any failure. Now what I'm doing is I'm running a post method again against the task, meaning I'm submitting another job. But here I'm not giving the JSON file. I'm just providing the task ID, meaning I'm resubmitting that task that I already had, but now using the mode deploy, no longer the mode analyze, meaning first I analyzed my AutoUpgrade task and now I'm deploying it. So I don't need to provide the same JSON again. I'm just reusing the same task ID, now using a new mode, which is the deploy mode. And here you will see the status, this job was submitted. And now if I want to get the log, all the files that were creating during this execution, I can load against the log endpoint, providing my task ID. And here I have the list all of the files that are created during this job execution. And what I can do is I can copy this URL here for a given file name that I want to check. And I can efficiently open a web browser and paste this link. And then I will be able to see the HTML file doing a REST call using the browser. So that's the same as using curl, but here the browser is translating the HTML output in a visual form for me. So here, for example, I can check the status of my AutoUpgrade task. All right, now let's see a demo of this REST API working. So first what we do is we create this upgrade.json file. And here we are upgrading a database from 11.204 to 19C, as we can see on the parameters. So I'm running the post method first in mode analyze. And here we have the task ID. Optionally, we can also get the task ID running a get against the tests endpoint. So here we have the task ID again, or we can even open this endpoint in a browser and get the list of all the tests we currently have for this AutoUpgrade job. So if I want to check the console output, I can go against this endpoint here, /console, and here we have jobs finished without any failure. And we can also get all the log files that were created during this task. We go against this log endpoint. And for example, the file I'm interested in right now is this pre-upgrade.html file. So we can copy the link, put in a browser, and here we have the list of all pre-upgrade tests. And the first one here, we had a failure, but it has an auto fixup available. And we can scroll down and see the list of checks that were performed. If I check the status.log file through REST call, I see here that checks passed and no manual intervention needed, meaning this analyze was 100%. So now I go with deploy mode against the same task. So I don't need to provide the JSON file again because I'm rerunning it with deploy mode now. So here we see task was submitted. And if I want to get the console output, we see here the stage, it's on the pre-checks stage. Running the same command again, it's on the pre-fixups stage. Checking the console output again, still on pre-fixups. Now start the DB upgrade stage. Of course, I'm speeding up a bit. If I want to check the logs files created again, I can go against this log endpoint. And here I run a screw up. So scrolling up, and I'm trying to find this one here. This is state.html. So I copy the link, I paste it on in the browser, and then I can now keep tracking of my upgrade job through web browser. I don't need to run REST API calls using this URL. You can also use your browser if you want. So checking again the state, we see here on the console output 10% upgraded. So we can also go again this progress endpoint to get the progress of this task. So here we have the attributes percent completed. We see 14, meaning we can also put this in a program and get the value using this REST call. So again, checking the console already now in the post upgrade, and job finished. So job finished without any errors. So my database was fully upgraded. All right, if I want to get the log files that were created again, I can here screw up. And we see here status.html. If I open this status.html and also the stats.log. So for the stats.log, we see that everything was success. And for our stats.html, we can open the browser and see that everything passed and everything was okay.
Now let me go on with the next chapter. And it's a mixed chapter with two topics, but one goes into another. First of all, we would like to show you a significant improvement for CDB upgrades, and then go a step forward and show you a significant improvement for RUC upgrades. Let me start with this one here, and it's called proactive fixups. The idea is we get much faster upgrades in CDB environments with many CDBs, and more CDBs here benefit the most from this new feature. What is it? It's a performance feature, so it's simply tailored to make upgrades run faster, and it basically changes only the order of certain tasks in AutoUpgrade. It isolates, in addition, errors in PDBs, and what I tell you now in the next 5 minutes is only valid for CDB upgrades. It does not apply to non-CDB upgrades. So this is a classic flow when we do AutoUpgrade. AutoUpgrade creates a guaranteed restore point, pre-upgrade, pre-checks, pre-fixups, and then in the second line, DB upgrade, afterwards post-checks, post-fixups, post-upgrade. That's the standard, and it still is the standard for non-CDBs. No change here. But when we have a CDB environment with many PDBs, what happened in this workflow? At first, you saw the pre-fixups, standard. And once the pre-fixups were completed, then we entered the upgrade of CDB $root. Also, nothing changes here. But where we change now something, and it's this part. At standard, all the PDBs were now upgraded in certain groups. So group 1 was first, and group 2 was second, and so on and so forward. And once the groups were upgraded, then we could go on to the next step, post checks, and so on. So depending on when you had like one problematic PDB in here, which took much longer, it could delay the entire process significantly. Post checks then at the end. Now the new flow, you say, hey, wait a bit. This is the slide I saw before, and right, it's exactly the same slide you saw before. No change when we talk about CDB $root. Absolutely no change. But as we upgrade now PDBs here, after CDB $root has upgraded, we extend the process into the PDB upgrades. And here we do now a significant change. Here we have now the possibility to isolate upgrades, post checks, and post fixups on PDB levels. So we don't wait anymore. Let me show you what that means in the PDB upgrade stage. We start upgrading our 4 PDBs here, but one is finished, so it can go to the post checks and the fixups already. And you see, all can do this. So whenever a PDB is done, it can go to the next stage already. And when you look at the output about the stage progress, here in this output we created, you see that PDB $seed, the first one, is still in DB upgrade. It usually takes the longest of all PDBs. And some PDBs like PDB 1, 3, 4, and 5 are already in the fix-up phase, while PDB 2, 6, 7, 8, and 9 are still in the upgrade phase. And so it has another impact here. You see, when we take this now overall, we have 4 PDBs and root container and 4 cores, fairly small environment. And ignore the first 4 lines. We look at the 5th line, the DB upgrade, 133 minutes versus 130 minutes on the right side with the new proactive fixups. But the really important line here is this one here, the post fixups. Since this ran in all 4 PDBs at the same time, especially the recompilation, that costs a lot of resources. While now it just takes the resources available. And so our upgrade here decreased from 3 hours to a little bit more than 2 hours. That's a significant improvement. And another test here, 16 PDBs and root container, 8 cores, all the AutoUpgrade defaults used. No magic done, no hidden tuning parameters we don't tell you about. And again, we look only at the DB upgrade line and then at the post fixups line. So you see post fixups went down from 46 minutes to less than 1 minute, since a lot of the actions had happened asynchronously before and not all at the same time. This is a significant improvement again here of over 1 hour saved in the entire upgrade. And the more PDBs, obviously, the greater the impact, the greater the benefit is. If you have just 2, you won't see much benefit, a little bit maybe, but if you have like 200 or 150 PDBs, then you see a much, much bigger benefit from that feature. And on the side, the proactive fixups also isolate each PDB. So an error in any PDB do not affect other PDBs. What does this mean? Let me show you that here. By default, one problem in one PDB may halt the entire upgrade. The job can't complete. So you can just revert and then start again. Now with the PDB isolation automatically implemented with the proactive fixups, one issue in one single PDB doesn't stop the entire job. The upgrade job of all the others still completes, and then you can sort out and fix what has gone wrong here. The restore point right now protects the CDB on CDB level only. So the restore point AutoUpgrade created, you remember the green flowchart? It protects the entire CDB. So when we go back to the restore point, it rolls back everything. In addition, if you want your PDBs to be available once they are done, by default, this does not happen. So when you look at the flowchart here, you see CDB $root always gets upgraded first, and then my PDBs, and they have finished at different times during the proactive fixups. But by default, the entire environment is just available once the last PDB has been upgraded. Now we introduce a new parameter in AutoUpgrade. It's called make_PDBs_available, and the default is false. But if you would like to have PDB 1, 2, 3, and 4 be available as soon as they are upgraded, we can change that. Make PDBs available true, and this means now PDB 1 is available, PDB 2 is available, PDB 3 is available, and PDB 4 is available as well as soon as it was upgraded. So that can be quite helpful as well. And with this, I hand over to Daniel now for distributed upgrades.
Thanks, Mike. You just made my upgrade faster, but I want it to be even faster. So let's look at distributed upgrade. This is a feature that builds on top of the proactive fixups that can make your upgrades of container databases even faster. So let's dive right into it. We already saw this picture previously when we talked about proactive fixups. We know that all the PDBs are being processed in batches on the computer where the upgrade is started, where AutoUpgrade is running. But what if we could do this on RAG systems? What if we could use all the nodes in the RAG cluster? That could potentially make the upgrade run even faster. And this is when we introduced distributed upgrade. This is a performance enhancement that applies to RAG systems running container databases. The more PDBs you have in your container database, potentially the bigger gain there is from using not only proactive fixups, but also distributed upgrades. What happens? Well, first of all, we upgrade CDB $root. We do that in the traditional way with cluster database set to false, and we do it on the node where AutoUpgrade is started. After that, we restart the container database and set cluster database to true. Then we can use all the nodes in the RAG cluster to process all the PDBs in batches assigned to each individual node in the cluster. This is how we used to upgrade rack databases. When you start auto-upgrade on one of the nodes in the cluster, auto-upgrade would set cluster database to false. First, CDB $root gets upgraded, and then in batches, all the PDBs are being upgraded as well. But look at node 2. It is doing absolutely nothing. And you could have many nodes in your rack system. None of the other nodes would be doing anything, just sitting there idle. So this is what you can do now with distributed upgrade. First, we still upgrade CDB $root, and we do that with cluster database set to false. Then AutoUpgrade will restart the container database and set cluster database to true, spawn itself on all the nodes in your cluster to process all the PDBs in batches in parallel using all the nodes in the rack cluster. When you use the AutoUpgrade console to monitor the progress of your upgrade, with distributed upgrades, there's now an additional column called node, where you can see on which node in the rack cluster that this specific PDB or this specific operation is actually running. If you want to use distributed upgrade on your rack system, it is super easy. There's just one line you need to add to your AutoUpgrade configuration file. Tune setting, proactive fixups equals true, comma, distributed upgrade equals true. You must use proactive fixups when you want to use distributed upgrade, because distributed upgrade builds on top of proactive fixups. In a later release of AutoUpgrade, we will make the syntax slightly easier, so you don't have to actually specify proactive fixups. It'll come kind of out of the box when you specify distributed upgrade. But for now, in the current version, you need to specify both. And then you simply just start AutoUpgrade in deploy mode like you're used to. This is the only thing you need to do in order to enable distributed upgrade. Under the hood, AutoUpgrade will take care of the rest. First, it'll build a second configuration file based on the configuration file that you provided, which has all the information needed in order to split the workload out on multiple nodes in the rack system. All the upgrades are split into batches, and each batch is assigned to one node in the cluster. We have database batch 1 and database batch 2. So in this example, it's a 2-node cluster. The SID is adjusted to the SID, the actual SID on the rack node where that specific batch will run. And when you look at the PDBs, we take the entire sum of all the PDBs, split it into batches, and assign a batch of PDBs to each of the nodes in the rack cluster. Then AutoUpgrade will spawn itself on all the nodes in the system. It'll use the special configuration file that AutoUpgrade created under the hood and start AutoUpgrade in a special way that you should never start AutoUpgrade like this. This is simply to illustrate what happens underneath the hood. We're using AutoUpgrade in a special mode that allows the use of distributed upgrade. I prepared a little demo where we can see how easy it is to use distributed upgrade and what actually happens underneath the hood. I have a directory where I create a configuration file, a 12.2 to 19C upgrade, and I enable distributed upgrade. Nothing fancy there. Then I use AutoUpgrade to run an analysis of the container database. 1 CDB, 10 PDBs. Let's look at the summary report. All good. We can just go ahead with the upgrade. My system is a 32-core system, so it's pretty powerful. And as we saw from the analysis, we have a container database with 10 PDBs. Let's do a count on $GV instance to see how many nodes we have in this cluster. 2 nodes. Okay, so it's a 2-node rack system. So let's go ahead and run AutoUpgrade in deploy mode. Let's start the upgrade. Let's see, LSJ creating a restore point, and then I'll use the status command to get some more details. Okay, we're creating the GRP. That's one of the first phases in the operation. I can use the hwinfo command. Very nice command here. See 32 cores. Now we are in the pre-checks phase and pre-fixups phase. So we are preparing the database for upgrade. Drain phase, so this is right before the upgrade actually starts on CDB $root. I'll use the status command and set it to refresh every 60 seconds. A little later today, we will show you this new cool console command. Mike has a demo on it. And now CDB $root is upgraded and we are in the post fixups phase. Post upgrade, and very shortly AutoUpgrade is now processing all the PDBs using the 2 nodes in the rack cluster. It has distributed all the PDBs onto the 2 nodes in the cluster. So let's see what's actually happening on node 2. I find all the AutoUpgrade processors, and here we have AutoUpgrade. We're using a directory underneath Oracle Base as a working directory. And this is the special mode that AutoUpgrade respawns itself in. This is what allows the use of distributed upgrade. And this is the special configuration file that AutoUpgrade created itself based on your configuration file. So let's have a look. And you can recognize the pattern here. We have multiple batches, and batch 2 is assigned to the node AU2, which is the node that we are currently working on. And as you can see, the set of PDBs that are scheduled to run on this node is also being upgraded. We can see that from the call to the DB upgrade script that works on each of the PDBs. Going back to node 1, we can see that the upgrades are still well underway. Post fixups are also happening distributed. So it's not only the upgrade, also the post fixups. And then eventually the upgrade completes. All is good. So very easy to enable distributed upgrade. And there is potentially a very big gain from using not only proactive fixups, but also distributed upgrade. We did a benchmark on a 2-node system with 4 CPUs. The blue column are the standard rack upgrades that AutoUpgrade has been able to do for many years. This is how we used to upgrade rack databases. If you enable proactive fixups that we talked about a little earlier, there is a gain. You can see that from the red columns, they are smaller than the blue columns, meaning that the upgrades complete faster with proactive fixups. But the huge benefit actually comes from distributed upgrade, which is the yellow column. It is much smaller than the red and the blue column. So our benchmark shows that there is a huge gain from using distributed upgrade when you're upgrading container databases on rack systems. The more nodes you have in your rack cluster, the bigger benefit that there will be. If your rack system is just doing this specific database upgrade, you can utilize all the nodes in your rack system to get them a fastest upgrade. But if you have other things running on your rack system, you might not want to use all the nodes in your cluster. And for that purpose, you can specify how many nodes of the cluster you want to use. Imagine I have an 8-node rack system, but I only want to use 3 nodes for this specific upgrade. Well, I can use the active node limit parameter for the tune setting and set it to 3. That way, AutoUpgrade will only use 3 of the nodes to perform this upgrade. Now that my container database upgrades have been made blazingly fast on rack systems and on regular systems as well with proactive fixups, let's investigate the new changes for DataGuard.
Well, I think you can see that we've made some pretty significant enhancements to our support for RAC databases, especially with distributed upgrade in a RAC cluster. Now let's shift a little bit and talk about what changes we've made to our data guard support, because this is something that is going to be very important for you to know about if you're upgrading in a data guard configuration. The main thing that we're going to talk about today is that the default for your defer standby log shipping has changed in AutoUpgrade. And there's a good reason for this. I'll explain why we have changed deferring of log shipping from yes to no. So by default, AutoUpgrade used to defer log shipping during the upgrade. And the idea behind that was that we wanted you to have an untouched standby as a fallback option while you're upgrading your primary database. But we've changed that default to enable redo transport and apply during the upgrade. And the reason for that is that we did this in consultation with the MAA team, the Maximum Availability Architecture team, who knows all things disaster recovery and availability related. Their recommendation is to keep redo transport up so that the standby is up and available much faster after the upgrade. So to compare what the world was like before and after this change, before we were in maximum protection mode. Your standby was going to be untouched during the upgrade of your primary. After, we are now in maximum performance mode. Your standby is up much faster after the upgrade. So the original was kind of the upgrade team recommendation. We tend to be very conservative when it comes to making sure that you have fallback mechanisms in place. I'm sure you're aware of that, the way we talk about guaranteed restore points and backups, and in this case, standby. But the MAA availability is about more than just fallback. It's also about how quickly things become available. That includes your standby. So in order that you're not flying with just a primary and a standby waiting to catch up, going into maximum performance mode made sense. So this means that while before redo log transport was deferred during the upgrade, now you will find that redo transport and apply are active during the upgrade. So that means that while before, if you have redo transport deferred, you're protected in case of upgrade failure by both a guaranteed restore point and having that standby available. Now the fallback mechanism would really only be that guaranteed restore point. So this compares the before and after. I hope that makes it pretty clear for you. So the concept here is, let's say you're upgrading from 12.2 to 19, a database where you have a primary in Boston and a standby in Chicago. What you would do is you would shut down the standby and open it in the new Oracle home first. And then you would use AutoUpgrade on the primary to upgrade that primary database and get it to 19C. And then what would happen is your standby will be upgraded just by virtue of the redo apply from 19C to that Chicago standby. So that's what will happen when you're upgrading in a data guard configuration. And that, of course, is a primary first upgrade. It is a little different if you're doing a data guard rolling upgrade. That's a whole different story. We're not going to talk about that right now. But let's go through a demo of this, because that, of course, with boxes and arrows and all that, that's always more simple than reality. And especially when you'll see that a lot of the steps for just that simple phrase of open the standby in the new Oracle home are something that you're going to want to take care of. So what we have here, I mentioned that we have our Boston primary, our Chicago standby. So we can go into the data guard command line interface and just examine the configuration. That will show us that we have the primary database and a physical standby, and we have the name of that Chicago standby being some disaster recovery type name. Once we know that, then we can go to the Chicago standby. And remember, the first step was to open the standby in the new Oracle home, but there's a lot more to it than that. So first, what you want to do is make sure that when you move to a new Oracle home, all of the files that you need are in the right places. For example, your data guard broker config files shouldn't be left in your old Oracle home. In this case, they're outside the home, so in a good shape. Then we want to create a restore point on the standby as a fallback mechanism. So we create that restore point, and then we need to shut down the database and move it to the new Oracle home. So we use servctl because in this case we're in a rack environment. So we shut down the database, and we take a look at some of the other files that are going to be necessary here. For example, our SP file, great, that's not in the old Oracle home, so we don't have to move that. But by default, your password file is in a location in your 12.2 home. So we're going to copy that to the new 19C home. Likewise, we have to move the TNS admin files, the things that are going to govern connection to that database. Those need to be moved to the new Oracle home as well. And then we look at the Aura tab, because DataGuard isn't going to automatically detect that you had moved this database and started up in the new Oracle home. We want to make sure that the Aura tab is current. So we go edit the Aura tab and give it the new Oracle home location. Finally, we start the database in managed recovery mode in the new Oracle home. And that means telling servctl where the database is going to be, or what binaries are going to be used to open that database, and starting up the database in mount mode using that Oracle home. We get the status of it, and we see that the instance is mounted. So this means we can now be in managed recovery mode, managed by the 19C binaries. All of that done just for that simple open the standby in the new Oracle home. By contrast, upgrading that primary database is dead simple. All you have to do is you have your simple command, your config file here with your source and target Oracle home, log file location, upgrade SID, and then we use one command to upgrade the database. Now, in this case, the database is a CDB with 2 pluggable databases, so it'll take some amount of time to upgrade, depends on the complexity of the database more than anything. But once it's done, then you'll see this note here that says, drop the guaranteed restore point from your database once you're happy with it. Now, that once you're happy with it means that you, the DBA, should go take a look at your configuration before you go dropping those guaranteed restore points and make sure everything looks good. Make sure that the databases are up, that your redo logs are shipping properly, and so on. So we can look at our configuration using the DataGuard command line. We see that, yes, our primary is up and running and transport is happening there. We can go look at our standby, make sure that transport is happening to the standby and that our apply lag is minimal. In this case, can't get much more minimal than 0 seconds, so we're in good shape. Now that we've verified that we're in good shape, now let's go drop that guaranteed restore point that was our fallback mechanism. So we connect to the primary, get the guaranteed restore point, and we drop it. But there's one more step, because remember, we also created that guaranteed restore point on the standby. So we can likewise connect to the Chicago standby, find the guaranteed restore point there, and drop that. And once you've dropped the restore point on the standby, everything is up and running, and you've now upgraded your DataGuard configuration. So again, the most complicated part of this whole step was what sounds so simple: shut down the database and start it in the new Oracle home. But there are several steps to take care of there, and that's what we wanted you to be aware of.
Thanks, Roy. Now, if you need to deviate from the defaults, if you need to change the defer standby lock shipping parameter so that redo transport is disabled during the upgrade, there is something you need to be aware of. When you set the parameter defer standby lock shipping equals yes, AutoUpgrade before the upgrade will ensure that redo log transport to all remote log archive destinations are deferred. A standby database is a remote log archive destination, and we want to ensure that redo doesn't go there, so all is good. But log archive destinations are used for other things as well, like for instance, Golden Gate downstream capture per PDB DataGuard, or zero data loss recovery appliance has a feature called real-time redo transport. All those features, you enable them by setting a remote log archive destination in your database. There is no way for AutoUpgrade to distinguish between each of them, so all remote archive destinations will be deferred. So you, together with the business, need to decide whether or not this is acceptable. When you have a container database that is protected by DataGuard, and you put in a new PDB to that container database, special attention is needed. For instance, during Unplug-plug upgrades or non-CDB to PDB conversions. The catch here is that when you plug in a PDB on the primary database, on the standby database, the location of the data files making up that PDB has to be the exact same as on the primary database. Otherwise, if the data files are not in the correct location, the MRP process will crash, and the MRP process, that is the process that does the redo apply. So effectively, the standby database is out of business because redo cannot be applied. To work around this unfortunate situations, there is now a new configuration file parameter in AutoUpgrade called Manage Standbys clause. The default value is none. This means that whenever AutoUpgrade has to create a new PDB using the create pluggable database statement, it'll automatically append the standbys equals none clause to that command, unless you change it, of course, away from the default. But if you don't do anything, AutoUpgrade will use the standbys equals none clause. What does that cause? Imagine this situation where I have a lower release container database and I want to unplug a PDB and plug it into a higher release container database that is part of a data guard setup. You create an AutoUpgrade configuration file to perform an Unplug-plug upgrade, and it looks something similar to that. When you start AutoUpgrade in deploy mode, underneath the hood, at one point in time in the target container database, AutoUpgrade will create the PDB with the standbys equals none clause. The effect of that clause you can see when you run the show PDBs command. In the primary database where the PDB was plugged in, the PDB will be open unrestricted in read-write mode. All is good, you can start to use the PDB. But if you run the same command on the standby database, you will see that the PDB is mounted. Even if you have active data guard and you open the standby database, the PDB will not go in read-only mode, it will stay in mount mode. It simply cannot reach a step beyond mount. It is stuck in mount mode. And the reason for that you can find in $PDBs on the recovery status column. It is set to disabled. So recovery on PDB1 is disabled. And in order to work around that situation, you need to restore the pluggable database onto the standby database. You can restore it from the primary database using the from service syntax. You then need to enable recovery of the PDB and then online all the data files that make up that specific PDB. This, of course, takes time and it requires I/O and network bandwidth. So for non-CDB to PDB conversions and Unplug-plug upgrades, where the target is a container database, it means that for a period of time after the plugin operation, the PDB is not protected by your standby database. Of course, the PDB works on the primary database, but if you do a switch over, that new PDB will not work on any of the standby databases until you have restored and recovered all the data files onto each of the standby databases. There's a really good Moz note with step-by-step instructions on how to actually do that. This, of course, is a problem if you have a PDB that is 100 terabyte. You need I/O and you need network. It takes time to copy that PDB. If you have an SLA that dictates that no users can connect to the PDB unless it is protected by data guard, it means that you need to extend the downtime window until you have restored and recovered the data files onto the standby databases. In such situations where such an increased downtime is not acceptable, you can, of course, reuse the data files on the standby database to ensure that the PDB is immediately protected. To use that feature, you can use the manage standbys clause in AutoUpgrade and set it to all or a list of the standby databases. This will ensure that the PDB is immediately protected on the primary database and on all of the standby databases, but you must follow a special procedure, and you have to take care about this catch that the data files must be located on the standby database in the exact same location as on the primary database. Otherwise, you end up in problems with the MRP process and redo apply. There's a link to this really good Moz note with step-by-step instructions on what you need to do in order to reuse the data files on your standby databases for Unplug-plug or Non-CDB to PDB conversions. But let's try to understand what the real issue is here. Because if the PDB is already part of a data guard setup, then you have the data files on the standby databases already. Why can't you use those data files? That's a really good question. Let's start to investigate the source database, a 12.2 database, container database, which is part of a data guard setup. If you connect to the primary database and look in $data file, you can find a list of all the data files that eventually make up all the table spaces in your database. Let's look at the last line, which is the data file that make up the user's table space. It's the exact same data file, but as you can see, the file path is different on the primary and on the standby database. When you use ASM or when you use the OMF naming standard, it dictates that the database unique name must be part of the file name path. And also in ASM automatically appends a unique number to the end of the data file in order to ensure uniqueness. So when you have a data guard setup, the same data file will always have a different name on the primary and on all the standby databases. When you unplug the PDB, you use the alter pluggable database statement and you unplug it into a manifest file. If you look in the manifest file, if you scroll down to the bottom, there's a list of all the table spaces, and there is a list of all the data files and the path to those data files. But the manifest file contains only the file paths on the primary database, not on the standby database. This becomes a problem when we want to create the pluggable database in another container database. We use the create pluggable database statement and we specify the manifest file. But the manifest file only have information on the data file locations on the primary database. So how on earth is the standby database to know where those data files are located that it needs in order to plug in that PDB? This is the problem. Then you might think, I'll just move or copy the files in ASM. But ASM and the OMF naming standard dictates that only a database is allowed to produce or copy files and give it a name that is a proper OMF name. So if you try to copy the file into the right location, ASM will give you an error because only a database can put the file in the right location. So what can you actually do? Luckily, there is a solution, and that is to use ASM aliases. On the standby database, we can create an alias that points to the path of the data file on the primary database, but we then point it to the location or to the real data file on the standby database. When you then create the pluggable database on the primary database, if you look in the alert log on the standby database, you can see that the standby database is so smart that it can follow the alias into the right folder where the data file is located and eventually plug in that data file to the standby control files, and then redo apply can start to do all the work and all is good. If you need to reuse the data files, you have to follow this special procedure, which is highlighted in the Moz note we saw a little earlier, and you must ensure that you do it right. Because we don't want you to jeopardize your data guard setup. You create a data guard setup, you have multiple standby databases because they are important to your business. probably part of your SLA, you must have one or multiple standby databases ready in case of a disaster. So we don't want you to jeopardize those important standby databases, which means that when you need to do these unplug-plug operations or non-CDB to PDB conversions in a data guard setup, be sure to test and be sure to verify your procedure afterwards. Potentially do a data guard switchover after the upgrade to ensure that the new PDB also work on your standby databases. We don't want you to jeopardize your standby databases. Enough about data guard and standby databases. Now we will talk about some very cool usability features that also came into the latest version of AutoUpgrade.
Now it's time for the final chapter. Some fun stuff, some interesting features, usability. And even there, we improved AutoUpgrade. So first of all, a few new console commands. And those should ease your AutoUpgrade experience quite a bit. First of all, if you ever wondered why LSJ, the most often used command in the AutoUpgrade job console, has no sort of auto repeat, it has that now with LSJ -A, and then you define a number of seconds, like 10 seconds. And then it repeats itself and you don't have to sit there. Even though, as we showed you before, we all prefer monitoring it in a browser. But in case you want to have the console or there's no browser available for AutoUpgrade monitoring, this is a good way as well, especially if you have more databases. Pro tip here, the repeat interval is between 7 seconds and 1,200 seconds, but not less than 7 seconds. Then, just with a slash, you can repeat the last command. You may notice from the bash, same thing, slash repeats the command, does exactly the same. And H or hist gives you history. Numbered history, so /1 in this example just executes the command stored here under 1, or /4 would execute a help again. Very simple. And then one thing in addition, status -config, you know, maybe status -job and then the job number giving you more information about the job, but status -config gives you more information about the current job, such as here the Oracle SID, or if you're upgrading to a target CDB or not, other things, tune parameters, and so on, some system parameters, which upgrade fatal errors, will just break the upgrade and such. And one thing we would just to have stand out here is AutoUpgrade. Take this as a teaser. There's a new feature coming very, very soon for AutoUpgrade, which has to do with patching. And I think it's one of the most requested features for AutoUpgrade since day one. Now let me show you a quick demo here. So what we do here in this demo, we do an AutoUpgrade with fixups. So I kick off my fixups and LSJ, I can do that, but I can also use a slash, as I showed you before, slash repeating that, or LSJ -A, 3. 3 does not work. 7 is the minimum. I should have read the documentation before. So 7 is the minimum, and now every 7 seconds, it will refresh the screen and repeat the command automatically. And just if you want to exit it, simply press enter and exit it. Let's do that now. Enter. Quick check with the history. /1 gets me the error again. Needs to be 7 seconds, so I should do /2 here, and this brings back the LSJ -A7 command again and repeats itself. Very simple. Now, final usability features.
Thank you, Mike. There is a new command, fxlist. fx stands for fixups. So here you get the list of all the fixups you have for a given job. So this command will give you the pre-fixups list as well as the post-fixups list. So you simply run fx list minus job and the job number, and then you have this list. What is quite interesting in this command is that you can change a fixup from executing or not. So you can run this fx list minus job and minus C where you specify the database. So if you're running an upgrade for a CDB with 10 PDBs inside, here you can tell which PDB you want to enable or disable a given fixup. So minus C is for database name. Then you say alter the fixup job, and then run no or run yes, or even run skip. So if you put run no here, you see that the job will not execute. So opening a demo and checking this happening. So here I have this job running, LSJ, job 100, and fx list minus job 100, then I get the list of pre-fixups and post-fixups jobs. And here what I'm gonna do is I will change this old time zone exist fixup from yes to no. So here, fx list minus job 100 minus C db12, alter old time zone exist run no. So after I run this, it says that the fixup was updated. And when I get the list again, we see here we have a no for this fixup. Okay? Okay, another thing that we have now is that during a multi-tenant upgrade, we restrict the resource consumed during recompilation by UTL-RP. So what does that mean? Imagine you are recompiling a CDB with 10 PDBs inside. We are gonna cap the maximum numbers of PDBs that can be running UTL-RP at the same time. What are the default values? So the default values is the number of PDBs that you can be recompiling at the same time is this total number of CPUs divided by 3. Meaning, let's say you have 30 CPUs, it's gonna be 10 PDBs in parallel, no more than 10 PDBs in parallel. And each of those PDBs by default will get 3 threads, meaning 10 multiplied by 3 will be back to 30, which is the number of CPUs you have, okay? So remember that recompiling is a very CPU intensive task. So for example, when we run a cert command here, we see that the percent user, which means the total amount of CPU that's being currently used, is almost 100% here. So UTL-RP recompiling is very good when there is only one database in the host and you are upgrading that database. But imagine you are upgrading a database while you have some other databases also running on that same host. Then during the recompilation phase of this database that you are upgrading, you may starve the CPU resources for the other databases. So for that, there are some new parameters that you can specify to control the maximum number of threads that the recompilation will occupy. Those parameters are UTL-RP PDB in parallel and UTL-RP threads per PDB. So as I said by default, the first one here is number of CPU count divided by 3, and the second one by default is 3. If you want to change, you can using this stun setting parameter in the AutoUpgrade config file. So here, for example, if we say that we want no more than 3 PDBs in parallel, each PDB with up to 4 threads, this means that we are gonna use no more than 12 cores during the recompilation phase. Another thing that we have in AutoUpgrade is now what we call fast deploy, which also reduces downtime. So the standard way is first run the analyze mode and then run the deploy mode, which is gonna rerun the analyze mode with fixups and upgrade. What we have now with the fast deploy is that you can run the analyze and the fixup modes and then run upgrade mode. So you can separately run each of those phases. Before you could not do that. You could only do this if you were moving to another server. And if you want to go separately before, you will need to perform some custom actions, like you have to put your database in upgrade mode between the fixup and upgrade call. But now you don't need that anymore. You can run step by step, isolated, and AutoUpgrade will do all the required actions for you. So you can simply call analyze, then you call fixups, and finally you call the upgrade, all of them separately without requiring any extra step. But we don't recommend you to go that way. Go with the standard way, which is analyze and then deploy. And the reason why is that you may have a scenario where something happens to your database between you run the fixups and the upgrade mode. For example, someone's introduced a new hidden parameter there, and then it's gonna mess your upgrade process. So only go with this way if you really want to achieve the minimal possible downtime during an AutoUpgrade test. Now back to you, Roy.
Well, thanks so much for spending time with us in another upgrade and migration webinar. We hope you found the information about deeper use of AutoUpgrade useful, whether it's in DataGuard configurations with TD encrypted databases, rack databases, multi-tenant, or even a combination of all that, or if you want to take advantage of those new REST APIs. Now, let me take you back to that very first piece of advice that I gave you in this webinar. Do you remember what it was? It was to always use the latest version of AutoUpgrade. And you can get that from our Moss note. You can see the link here, and you can get it from the slides when you download them as well. And remember that we have a library of webinars available, everything from cloud migration to minimal downtime upgrades, or from multi-tenant to database upgrade internals. From the high level to the lowest level, we have you covered. Of course, you don't always want a 90-minute to 120-minute webinar to go through, and that's why we've broken a lot of these topics into smaller bite-sized chunks in the YouTube channel. If you're just looking for that one tip that you might have forgotten the details about, the YouTube channel is a great place to go because you can search on there and find that tip immediately. So thank you once again for spending the time with us. Remember that we have these blogs available from Mike, from Daniel, from Rodrigo, always very timely, useful, and always technical with zero marketing. So our YouTube channel link is here, along with the webinar link again. Why do we include it in so many places? So it's easier to find. And then finally, our next webinar. Well, I hate to tell you, but we're going to take some time off during the summer. Our next webinar isn't going to be until maybe November, December, and that's going to be some even deeper looking into Data Pump. We had so much information from our last Data Pump webinar that we couldn't even fit in 2 hours. We're going to come back to you with more detailed use cases and really good internals and technical information. But that won't be till the fall after Database World and all the craziness that entails. So thanks again for sticking with us, and we hope to see you soon.